Hello and welcome to the next episode of Vjeko.live. It is still the Inside Git, and today's topic is branching. So today we are going to talk about Git branches. What are the branches, how Git stores them, how Git tracks your branches, and what happens when you commit on branches, when you check out branches, create branches, delete branches, etc. Without much ado, let me first thank you all for following my blog. Thank you all for being here live with me. There is not too many of you, but yeah, still, I believe that over time the people will join and yeah. So anyway, as I said, without much ado, let's start talking about branches. What is a branch in Git? Let me first try to address this typical misconception. And I believe that a lot of people have this misconception of what a branch is in Git if they come from a non-Git background. Like, for example, if you've ever done a branch on Subversion, or if you've ever done a branch on, for example, TFS, then you may have a different experience of what a branch is. So a typical vision of what the branch is that it's something like this. So you have this, as you can see, this straight line that has a name. In this case, this is master. And then when you create a new feature, then, for example, you would call this branch feature 1. And then maybe you can start adding commits on this, and then you would have this vision of branch. That branch is simply this straight line that has a name. But this view of branches is actually very wrong. This is not how Git actually tracks branches. So let's try to take a look inside and try to figure out what exactly is a branch and how Git tracks branches. First of all, a branch is not just a named line of development that goes forward in future. Actually, branch is something a little bit different. It goes backward in future. And let's take a look at that. So I'm just going to show you a demo. It will be much simpler. So here I have a folder. I'm going to turn it into a Git repository. So I'm going to do git init. And now this is an empty repository. I can try to show log to see what do I have at this point in my repository, and I can see that my current branch master does not have any commits. So let's add a commit. So I'm just going to create file 1, and inside I'm going to create text line or write a text line, and then I'm going to just commit this. I'm going to call it first commit. And when I commit that, I can, of course, see that I have something in my Git history. And if I show a graph of this, I can see that this is where my master currently is. This is my master branch. This is where we can see the branch name as well. So let's create another commit now. Let me add another file. And I'm going to stage this and then add this second commit. And then I'm going to take a look at my graph, and I can see that master has now moved. I have my first commit and my second commit. And just for the sake of it, to show my point even more clear, I'm going to do file 03, and then I'm going to add some text in there, and I'm going to stage that and commit that. So this is going to be third commit. And I'm committing this. And let's take a look at the graph. Now I have 3 commits in my history. So as I said, a branch in Git is not one line that has a name and that goes forward into the future. A branch is actually something different. It is a line that goes backward in the future. If you take a look at this graph here, I have 3 commits, and those 3 commits actually follow each other. My master branch currently points to this last commit. So this is actually where my branch at this point resides. It's not a line that starts at first commit and then goes forward. It's actually a line that ends at this last commit and goes backward towards the last one. Just to get this in sync with my presentation that I was showing, I'm going to add another file and I'm going to commit that one too, and this is going to be fourth commit. I'm going to stage and commit this, and my graph now actually matches my presentation. So I have four different commits all on one branch. So let's take a look at what would happen if I would now create a new branch on top of that. So I'm now going back to my demo, and I'm going to create a branch. I'm just going to do create branch, and this is going to be feature 01. And let's take a look at what happens here. So Git will show me that now I have feature 01 and I have master. And you would not be mistaken to represent it like this. So if we take a look, this is what we really have. We have another tag that points to this master, to this last commit. So how does Git actually store this inside Git repository? So to see that, I'm actually going to reveal this file in File Explorer. And if you remember from my last session where I talked about how Git stores things, you remember this .git folder in which we have everything that relates to this repository. In fact, this is the repository. So we could actually go into this refs folder and then heads folder. And then here we will have these two files. One is called master and one is called feature 01. So let's take a look. I'm going to actually open both of them in my Visual Studio Code, and we can see what they are. My feature 1 contains something that you should know by now, or at least remember from the last session, that this is a SHA-1, and the next file is master, and it also contains SHA-1. And this is actually the SHA-1 of the same commit. And if we take a look at Git graph, we can see that this SHA-1 is in fact this commit SHA-1. So this thing here, and I'm now going to close these files because I don't need them anymore. This same SHA-1 is exactly what my both branch files point to. So to make it simpler, a branch in Git is nothing but this small file that has a name which resides in .git, then refs subfolder, then heads subfolder. And this file simply has a name that matches the current branch. Sorry, not the current branch, the branch. So here we have two small files. This means that we have two branches, and those files contain nothing else but just the SHA-1 of the commit to which they both point. Since at this stage we have two branches, both of which point to this last commit, this is what we have. So if we go back I apologize. I was again not showing the correct screen, even though this time I actually have it in front of me. So let me show it again. So here we have these two files, two branches, and what we have inside of our .git refs heads, we have these two files, and I've opened those two files inside of my VS Code. This is the first file, and this is the second file. As you can see, both of them contain nothing but just SHA-1 of this last commit. So this is my last commit, and as you can see, this SHA-1 is contained in here and in here. So this is how Git stores information about branches. There is nothing more about branches. The branch is nothing but this small file that has a name. The file name is actually the branch name, and the file content is the SHA-1 of the commit to which that particular branch points at. So what would happen if I would now add a new commit? So let's create a new commit. I'm going to add file05.txt, and then I'm going to stage this. And when I commit that, let's just actually switch to graph, and let's take a look at what happens when I commit this. So pay attention to the graph. I'm actually going to show it like this. Here I can see that I have my uncommitted changes, but when I commit this, I will get this situation. I have feature 1, which points to this SHA, which is B63F, and master still points to the same SHA that it pointed before. So if I take a look at feature file, I can see that it now contains this other SHA, and master still points to that old SHA. And this is in fact what Git branches are. So as I have added a new commit, this is what happened. So again, if I add another commit, and let's do that now, I'm going to open this file now, and I'm going to create, new, not there, but here, file 06, and this will be file 6. I'm going to store that. I'm going to keep this open. I'm going to my Git, I'm going to stage this, and then 6th commit. And as I commit that, you will be able to see that this feature 01 file has changed the contents. It will point to the SHA of this new commit that we will get when I commit this. So exactly this is what happened. I can verify that this is in fact the SHA of this 6th commit. This is the same SHA as you can see. So this is what happened when we added another commit. Now let's do something that we typically do when we work with Git. Let's actually merge this feature branch into master, and let's see what happens. So I'm going in here, I'm going to check out to master branch, and then I'm going to do merge branch, and I'm going to merge feature branch. So before I do that, I'm actually going to keep this graph open, and let's take a look at what happens when I do that. So, and for this time, pay attention to master. It still contains this old SHA. So let's do this merge. And then I'm merging feature 1 into master, and let's take a look at what happens. So master has updated, and it now points to the same SHA as the feature branch. So the thing that happened here is a fast forward. Fast forward is a situation where Git detects that to merge some other branch into current branch, it needs to do nothing else but move the branch pointer along. So let's take a look at this graphically. So this is the situation that we had before I did the merge. And then as I did the merge, as you can see, this feature branch, it is simply a pointer that is 2 commits ahead of master. So to merge feature into master, Git needs to do nothing else but fast forward this master tag to match the same one, the same pointer as feature 1. So let's take a look. This is exactly what Git did at this point. So Git has in fact simply updated the master pointer, and nothing else has happened. There was no new commit object. Nothing new has appeared in the objects folder inside Git repository. So this is what a simple fast forward does. So this is a typical situation that happens when you do local development, when you start a branch from somewhere, complete the work in there, and then update or actually merge that work into the branch from which you started. This is what happens. This is fast forward. This is the simplest way of integrating 2 branches together, and Git will always do that if it determines that it can, unless you explicitly tell to Git that you do not want that. But this is a little bit advanced now. I'm not going to go into integrating branches in this session. Let's leave it at this point. A typical thing that you would do with branches now is that you would delete this feature 1 branch. So you would do something like this. So what does that do? Let's take a look in the demo. I'm going to delete this feature branch. So I'm going to open this folder so we can see that we have 2 branches in there. And when I do delete branch and delete feature 1, the only thing that happens, branch is deleted, but the only thing that happened in here is that this file has disappeared. So I don't have that file anymore because I don't need it. I've deleted it, but that's the only thing that happened. Git didn't have to do anything else because the only thing that this branch really is that it is this small file that points to a specific commit. And when I delete the branch, I simply delete that pointer, this small file. Cool. So now that you have seen how Git was advancing those pointers when I was on feature 1 branch, how did Git know which pointer to advance? Because I had two branches. I had feature one branch and I had master branch. So obviously everything I did was done on the on this feature one branch. How did Git know that this was my current branch? When I take a look at how Visual Studio Code represents my Git repository, it shows me the current branch in here. And then if I create a new branch, I can do it from command line as well. Actually, I can do git branch feature 02. And when I do that, I have created a new branch called feature 2. And if I look up the branches from here, I can see actually, yeah, that's just, VS Code doesn't refresh that really. So let's reload this window and then let's see if Git will now be able to see that. Yeah, I can see feature 2 branch in here. So I actually have two branches, but my current branch is still master. How does Git know that master is my current branch? In fact, other than just keeping this small file called master inside refs heads folder, Git has another file called head, which is in the root of Git repository. And if I take a look at that, I can see that here in .git, I have this small file called head. And if I open that file, I can see that it points to ref, and then it points to refs, heads, master. This is simply the path to the file that contains the current branch. So Git has a special name for current branch. This current branch is a user-friendly name or developer-friendly name, but Git actually refers to it as head. So when you see this head in all caps, it refers to the current branch. This is what current branch is. And for example, if you remember from last time, I could do things like, for example, git cat file and then use SHA to see the contents of this file or what this object. I can do the same instead of with SHA. I can use head, for example, and then print. This head is nothing but a pointer. In fact, it is a pointer. Yeah, again, I was showing this not correctly. So let's take, let me clear this again. So as I said, I have this head file in here, and I've opened that head file, and it points to refs, heads, master. So it is just a pointer to this pointer, sorry, master pointer, and it is where actually current branch is. So if I go back in here and do git log, for example, and then I take a look at the last commit in this branch, and then do git cat file and use SHA to inspect the contents of this object, I could achieve exactly the same thing with git cat file master, because master points to the same SHA. But I could do the same by pointing, by using git cat file and then head and then p. I would get exactly the same contents shown on screen. That's because all of these are simply pointers. For Git, this head is just a pointer. Whenever you refer to head, Git will translate that to this. And then since this is also a pointer, it will translate that to this. So this is the pointer to, let me actually take a look at the graph. Yeah. So this is what we have done as we actually created those branches, as we committed to those branches when again when we switched to different branches. So what will happen if I now switch to this feature 2 branch? So if I take a look, I have my master and feature 2 both pointing to this same commit. But if at this stage I add another commit, for example, if I do this, if I create a new file and call it file07.txt and then commit this file, so 7th commit. So if I take a look at graph, what will happen is that this will be committed on the master branch. So my master branch will move ahead, and I can see that master contents have changed now. So Git has done that again because my head file points to master. It knew that master is current branch, so when I add a new commit, it must add it at that branch. So I wanted to do commit on feature branch, in fact, not on master branch. So let's take a look at what happens when I switch a branch. So I'm going to my Git graph. I can see that my feature is here, my master is here, and my head points to refs heads master. So if I do git checkout and then checkout to feature 2, what happens is that my head updates. And that's all. Nothing else has changed. Git has simply updated the contents of head file, and it has pointed my head to refs heads feature 02. And then simply by going into this refs heads feature 02, Git knows that this is where my current branch is. So when I add a new commit in here, I'm going to actually do that. I'm going to create file 8, and I'm going to do eighth commit, and when I commit that, now I can see this. I have my 8th commit and my 7th commit. So now I actually, for the first time, I start seeing these branches, and let's take a look at that graphically. So this is the point where I started. Then when I created my feature 2 branch, Git has simply created this small file. And then as I checked out into feature 2, this is what happened. So if I have added a commit on feature 2, I would have this. And then if I switch to master, this is the only thing that would happen. When I would then add a commit to master, this is what would happen. So this is similar, very similar to the situation that I currently have. So branches in Git are not those straight lines of development that go forward from a point. They're actually lines that go backward from the tip of the branch. This tip is what we call a head of the branch. That's also why Git has them stored like this, refs and then heads. Head is an internal name for a branch in Git. And this, please do not mix lowercase heads subfolder name. This simply means branches with all caps or uppercase head, which is just a single branch, which means the current branch. So this is what we have in Git when we actually start adding commits on different branches. Then we start seeing these diverging trees or diverging branches. But if we didn't work in parallel on multiple branches, we would not see that. And if you take a look at this feature 02, it is one straight line that goes into past, and master is also one straight line that goes into the past. Let's take a look at that from Git graph perspective. So currently I see all branches, but if I say I want to see only feature 2, I see this straight line that goes from the tip of the branch all the way down. And if I show master, I again have this straight line that goes from the tip of master backwards in history. It goes into the past. So Git branches are, just to summarize this, Git branches are nothing but pointers. They are small files that point to a commit. And since every commit tracks its history, it has its parent, that's how branches work. Branches are actually series of commits that go backwards in history from the current tip, from the last commit in a branch backwards all the way to the beginning of your repository. So that is what a branch is. Now in this picture here, you can feel that we have a feature branch and master branch, both of which start here. In fact, both of these branches start here. It is just that they branch off at this point. We could say that this is a base of the branch. And then from that base, we have feature 2 that goes in this direction. We have master that goes in that direction. And then later on, we could integrate these branches together. We could bring them together by, for example, merging feature 2 into master, or rebasing feature 2 onto master, or doing other things. So I'm not going to go into those. These are not the topics for today's session. I'm going to present more topics about Git in my live blog in the future, I'm also going to talk about rebasing and merging and different kinds of integrating. But if you want to learn more about this, I invite you to join me in my Git branching models and strategies webinar that I'm going to deliver on June 14th and 15th, which is in exactly 2 weeks. So this is another 2-session webinar where I go deep into Git branching. I explain how branches work in very deep detail. I also explain in very deep detail with all these kinds of graphical simulations that you could see. And I explain how you can merge, how you can fast forward, how you can rebase, for example, and a lot more. You will see different kinds of branch integrations. We would typically say branch merging. Merge is just one way to integrate. We have many different ways to integrate. So if you want to learn more, I invite you to join me in that webinar. And let's now address any questions that you may have. Thanks for watching. So let's take a look if we have any questions here. So I actually want to. Okay, it seems that we have no questions. I'm just going to type it here. Okay, so let me know if there are any questions. If not, you can always put your questions into the comments of this video. I will always answer the questions as soon as I get them, as soon as I get a notification. So it seems that there are no questions this time. Well, that's fine. Cool, thanks. Anyway, thank you very much for watching. If you like this video, click like, also subscribe. So you have, you have subscribe button over here. You also have notified button over here. If you decide to subscribe, then you will be notified whenever I'm delivering another session. I don't expect that I will have a session next week. Next week, I'm delivering a series of webinars, private webinars for a partner company, and then in 2 weeks I'm delivering the public webinar at this time. So I would expect that in 3 weeks there would be the next session of Vjeko.live, and at that time I'm going to go forward with some Git topics. I don't know exactly what it will be, but if you have some ideas what you would like to see, please also comment on that. It seems that I have a question. What about forks? What do you think about it? Well, I'm not talking about forks in here because a fork is not a Git thing. It's funny. A fork is a GitHub thing. Maybe other like Bitbucket, I don't know. Maybe they have forks too, but you do not fork in Git. So fork is nothing but a copy of a repository that tracks another repository. So in short, you could say that in terms of GitHub, fork is nothing but a remote that tracks another remote. And you do forks simply to track changes on another repository if you intend, specifically if you intend to do some, for example, custom development, like you decide to diverge your development from some other repository. Or another typical situation when you would fork is if you want to contribute. Then GitHub requires you to fork. So you would fork off a repository and then you would create pull requests against that repository from which you fork. But if you want to learn more about forks, that is a valid point or valid topic. But before we go into forks, we would first have to address remotes. And that is one of the topics I have for the future. I want to address how Git actually synchronizes with remotes. What is a push, what is a fetch, and what is a pull? So we will talk about these things. Yeah. So it seems there are no other questions really. So I'm going to close this session. Once again, thanks for watching. If you have any comments or questions, put them into comment section. And I'm looking forward to seeing you again, probably in 2 weeks in my public webinar, or maybe in 3 weeks in my live video blog. Thanks again and have a nice evening. Bye.